Howdy, howdy, howdy. Let's take a look at some examples. We want to make sure that we are able to factor polynomials of degree 3. Right? Now, I take a look. Got to make sure we're in correct order. So I see an x to the third, then the term with x squared, then the term with x, and the plain old number. And I'm looking at this, I'm thinking, hey, you know what? Not only does it begin with an x to the third power, it ends with a third power, right? It ends with a 4 to the third power. I also notice that both 12 and 48 are divisible by 3. So I'm thinking, hey, this is off of Pascal's triangle. I've got 1, and then I've got 3 times 4, and then 3 times 4 squared, and then 4 to the third. Right? That's what I'm really looking at. It's a 1, 3, 3, 1. So I'm just looking at x plus 4 quantity third power. All right, 4 times 3 makes the 12. 4 times 4 times 3 makes the 48. 4 times 4 times 4 made the 64. X to the third plus 64. I only see 2 terms, but they're both perfect cubes, right? I've got x to the third, and 64, of course, is 4 to the third. So if I rewrite it that way and go, aha, I've got a u to the third plus v to the third. So I'll need u plus v, which will be x plus 4. And then I'll need u squared minus uv plus v squared. Well, u squared will just be x squared. Then I'll need my minus. U times v will be x times 4. Well, of course, if I got x times 4, I'm going to write it as 4x plus v squared. Well, 4 squared is 16. Remember how those plus or minus signs work? If a plus or minus is followed by a plus or minus, you keep the sign. But if it's followed by a minus plus, you reverse the sign. Right? So when I see the u plus or minus v, I'll keep the sign I had. When I see the u squared minus plus the uv, we have to flip to the opposite. Holy cow, another polynomial to factor. Again, it ends with a 64, which is a perfect cube. But it's not a u to the third plus v to the third because there's extra terms in there. And it's not one of those Pascal triangle tricks because the coefficient of x squared is not divisible by 3, and the coefficient of x is not divisible by 3. So this is a factor by grouping. Got to look at the first 2 terms and ask myself, what's the greatest common factor? Well, greatest common factor is going to be x squared. Leaves me with an x minus 1. So that's how the first 2 terms factor out. Now I'm going to hide all that, and I got to concentrate on terms 3 and 4. What can factor out of terms 3 and 4? A negative 64. Leaves me x minus 1. Now again, for this method to work, whatever is inside that first set of parentheses must match whatever is inside that second set of parentheses. And sure enough, x minus 1 matches x minus 1. So now we can use the distributive property, but we're going the reverse direction than we normally would. Right? That x minus 1 multiplied by both the x squared and the minus 64. There's the x squared. There's the minus 64. Right? So it is now factored, but it's not factored completely because x squared minus 64 can become x times x. Signs don't match because there's a negative on the 64. There are no x's in the middle, so I need two numbers that multiply to be 64, but add up to 0. Well, 8 times 8 makes 64. 8 take away 8 makes 0, and so it works out. All right, so notice just because each polynomial ended with 64, which is a perfect cube, you could be in a situation where it's a binomial expansion. In other words, one of those Pascal triangle tricks. It could be a sum or difference of cubes, right? In other words, a u to the third plus or minus v to the third. Or it could be a good old-fashioned factor by grouping. Have fun with the assignment, and I'll be back in tomorrow. Right? It's just a one-day absence for me. And if you're still watching, you're pretty committed. But yeah, the word practice fades out, and now we are officially done.